Hello everyone, my name is Nikita. I am from EC branch. My subject is Digital System and Designs and my topic is Towards the Realization of Encoder and Decoder Using Deep Neural Networks. Encoder and decoder. Problems like machine translation, input and outputs are of varying length that are unaligned. The standard approach to handling these sort of data is to design an encoder and decoder architecture consisting of two major components: an encoder that takes a variable length sequence as input, and a decoder that acts as a conditional language model, taking in the encoder input and the leftover context of the target sequence and pretending the subsequent token in the target sequence. Let's take machine translation for from English to French as an example given as input sequence in English. They are watching. These encoder decoder architecture first encodes the variable length input into state, then decode the state to generate the translated sequence token by token as output. Re- Regarding since the encoder and decoder architecture forms the basis of different sequence to sequence model in subsequent sections, this section will convert this architecture into an interface that will be implemented later. The encoder and decoder architecture for recurrent neural networks in the standard neutral machine translation method that rivals and in some cases outperform classical statistical machine translation methods. The architecture is very new, having only been point in 2014, although has been adopted as the cone technology inside. In this port, you will discover the two seminal examples of the encoder and decoder model for neutral machine translation. After reading these port, you will know the encoder and decoder recurrent neural network architecture is the core technology inside Google's Translate service. The so-called for direct end-to-end machine translation. The so-called that extend the architecture with GRU units and an attention mechanism. Kickstart your project with my new book, including step-by-step the encoder and decoder architecture with the recurrent neural network has become an effective and standard approach for both neutral machine translation and sequence to sequence. The key benefits of the approach are the ability to train a single end-to-end model directly on source and target sentence, and the ability to handle variable length input and output sequence of text. In this post, we will take a closer look at the different research projects that developed the same encoder and decoder architecture at the same time in 2014. Model. An encoder and decoder architecture was developed where an input sequence was read in entity and encoded to a fixed length entity representation. Encoder and decoder is widely used structure in deep learning, and through this article we will understand its architecture. In these posts we introduce the encoder and decoder structure in same case known as sequence to sequence model. For a better understanding of the structure of this model, previous knowledge on RNN is helpful. The best way to understand the concept of the encoder and decoder model is by playing Pictionary. The rules of the game are very simple. Player 1 randomly picks a word from a list and need to stick the meaning in the drawing. The role of the second player in the team is to analyze the drawing and identify the words which is described. In this example, we have three important elements. Player 1, the person that converts the word into drawing, the drawing rabbit, and the person that guesses the word and drawing represents player 2. This is also we need to understand an encoder decoder model. Below, we build a comparative of the game and encoder decoder model for translating Spanish to English. A decoder network then used these internal representation to output words until the end of sequence token was reached. The network were used for both encoder and decoder. The idea is to use one to read the input sequence one time step at a time to obtain large fixed dimensional vector representation, and then use it then to use another to extract the output sequence from the vector. Model configuration. Input sequence were reversed. A thousand dimensional word embedded layer was used to represent the input words. Softmax was used on the output layer. The input and output model had four layers with 1000 units per layer. The model was fit for 7.5 epoch where some learning rate decay was performed. A batch size of 120th sequence was used during training. Gradient clipping was used during training to change of gradient explosion. Batches were comprised to sentences with roughly the same length to speed up computation. We translate the above graph into machine learning concept. We would see the below one in the following selection. We will go through each component. Encoder. Encoder means to convert data into a required format. In the Pictionary example, we convert a word into a drawing. In the machine learning context, we convert a sequence of words into Spanish into a two-dimensional vector. These two-dimensional vector is also known as hidden state. The encoder is built by stacking recurrent new neural network. We use these type of layer because its structure allows the model to understand context and temporal dependencies of the sequence. The output of the encoder, the hidden state, is the state of the last RNN time step. Hidden state. The output of the encoder, a two-dimensional vector that encapsulates the whole meaning of the input sequence. The length of the vector depends on the number of cells in the recurrent neural networks. Decoder. Decoder means to convert a code message into intelligible language. The second person in the term playing Pictionary will convert the drawing into a word. In the machine learning model, the role of the decoder will be to convert the two-dimensional vector into the output sequence. The English sentence. It is also built with RNN layer and the dense layer to predict the English word. When we use an encoder decoder model, image capturing. Encoder decoder model allows for a process in which a machine learning model generates a sentence describing an image. It receives the image as the input and output as sentence sequence of words. This is also works with video. They address the problem of sentence length in the follows up paper title, in which they propose the use of an attention mechanism. Instead of encoding the input sentence to a fixed length vector, a full representation of the encoded input is kept and the model learns to pay attention to different parts of the inputs for each word input by the decoder. A similarly configured model is used although with bidirectional layer. The data is prepared such as 30,000 of the most common words are kept in the vocabulary. The model is first trained with a sentence with a length up to 20 words, then with sentences with a length up to 50 words. A batch size of 80 sentences is used and the model was fit for 4 to 6 epochs. The encoder and decoder recurrent neural network architecture is the core technology inside Google's Translate service. Sentiment analysis. This model understands the meaning and emotions of the input sentence and the output a sentiment score. It is usually rated between -1 negative and +1 positive, where 0 is neutral. It is used in call centers to analyze the evaluation of these client emotions and the reactions to certain keywords or company discounts. The method of current research all have good accuracy in the experimental result, but there are still many things that can be improved. Firstly, the extraction method of battery HF can be further improved. In practice, the amount of remaining charge is uncertain when the battery starts to charge, which makes it difficult to obtain complete charging curves. In addition, due to the difference between different types of batteries, the encoder and decoder model was originally designed for machine translation problem. The model consists of encoder and decoder, both of which are often built using a recurrent neural network. The function of the encoder is to encode the original input and the sequence to obtain a fixed length context vector containing the entire sequence information. The function of the decoder is to decode the context vector to generate and output a new sequence. Translation. This model reads an input sentence, understand the message and the concept, then translate it into a second language. Google Translation is built up to an encoder decoder structure. For more details, this follows a paper. This paper proposes an encoder decoder model based on deep learning to establish the mapping relationship between battery charge curves and the value of SOH. The model consists of encoder and decoder. The encoder is a hybrid neural network composed of two-dimensional convolution module, ultra high weight subspace attention mechanism module, and simple recurrent unit module, which can effectively encode the sampling data of the charging curves and generate the encoding sequences. The decoder is mainly composed of backpropagation neural network, which is responsible for decoding the encoding sequence and output as estimate of the SOH. For log encoding sequence, a decoder with attention mechanism is proposed to improve the estimation accuracy of the model. Experimental result shows that the proposed model has good adaptability to different types of batteries, can adapt to various sampling methods of charging curves, and has high accuracy. One of the major advantages of the conclusion. One of the major advantages of this model is that the length of the input and output sequences may differ. This opens the door for very interesting applications such as video comptuning or questioning and answering. The major list of these simple encoder and decoder model is that all the information needs to be summarized in the one dimensional vector for long input sequence. That can be extremely difficult to achieve. Having said that, understanding encoder and decoder model is a key for the latest advances in NLP because it is a seed for attention model and transformers. In the next article, we will follow the process of building a translation model with an encoder and decoder structure. Then we will continue by exploring the attention mechanism in order to achieve higher. higher accuracy. The working of the encoder is the same in both the training and testing phase. It accepts each token word and the input sequence one by one and send the final state to the encoder. Its parameters are updating using backpropagation over time. Finally, the loss is calculated on the predicted output for each time step, and the error are backpropagated through time to update the parameters of the model. You have found your way here, then congratulations. I hope you have found this useful sequence mentioning many resources on the topic. While the LSTM is capable of solving problems, a thousand dimensional word embedded layer was used to represent the input words. The input and output model had four layers with thousand units per layers. Thank you.